everyone, we're going to sketch a graph of this polynomial f of x and fill out some information. First of all, we're going to determine the degree. Since this is not in standard form, I'm going to put in my multiplicities. I have a 1 and a 1 and a 2. So the degree is 4, or n equals 4. And in behavior, we'll talk about in a minute. Just remember that we have an even number in 4. And also we have a negative lead coefficient. All right, and we'll talk about that in just a minute. Let's go finish some of this. We have y-intercept, so you let x be 0. Fill that in. So that's going to be 4. When x is 0, y is 4. And then we're going to look at our zeros. That's when y is 0. So that would leave this be 2. 2 minus 2 is 0. Negative 2 plus 2 is 0. And negative 1 plus 1 is 0. So we have negative 2 comma 0 that has a multiplicity of 1. And this one has a multiplicity of 1. So that's going to be 2 comma 0. Both of those have multiplicity of 1. And this one, negative 1 comma 0, has a multiplicity of 2. And that we need to know if it crosses the x-axis or not. The maximum turning point is our n, which is 4, minus 1, which equals 3. And this last piece, determine where the intervals where f of x is negative and where f of x is positive. We'll do that after we graph. So right now, let's talk about the end behavior. So what we need to know is that we have an even, the degree is even, and we have a negative lead coefficient. So even, negative, that's this part right in here. All right. So our degree was 4, but the graph comparison is that one. So basically it looks almost just like that, but it's a little flatter in here and it shoots down faster. But we don't really care so much about that. We just care about the general shape of this. So our end behavior, what we're looking at is where are we going to start, where are we going to end. And we're starting in quadrant 3, and we're going to end in quadrant 4. That means we have negative, negative in quadrant 3, and we have positive, negative quadrant 4. And as you look at, we're going to be looking at this piece right in here. As x gets larger and larger from 0, so does my y. My y gets smaller and smaller. Thus we have positive, negative. Positive for your x, negative for your y. Now, similarly, as x gets smaller and smaller from 0, so does my y. All right, and if you look at this, you have positive, negative. Where's x positive, where's y negative? That's going to be quadrant 4. Where's x negative, where's y positive? That's quadrant 3. So what we need to know when we graph, I forgot to write this down, so let me write it down. We have y equals negative x minus 2, x plus 2, times x plus 1 squared. So we're going to be starting in this quadrant 3, and ending in quadrant 4. Now, my zeros are at 2, negative 2, and negative 1. And on this graph, we're not going to worry about our min and max points. So this is what we're going to do. Both of these have multiplicity of 1. Those are odd numbers. So as we come to the negative 2, that's this portion, the multiplicity is 1. That means we can cross. We don't know exactly what's going on in here, but just kind of go back down to your -1. Now at -1, this part, we have a multiplicity of 2. That means I can't cross. What is my y-intercept? 1, 2, 3, 4. My y-intercept was 4. All right, so you make a U-turn and come back. Let's go up through 4 and come and hit 2 here. So when you hit 2, that's this portion. That has a multiplicity of 1 here. So that means you can cross, and there it is. All right, so there's your kind of shape of the graph. Now the only thing else we have to do is see where the graph of f of x is positive above the line, and where is it below the y equals 0. So where is f of x positive? Well, it's positive right in here. That's where it's above the graph, the y equals 0. So that's from -2 to 2. Now where is our graph negative? Well, it's right here. So that's -infinity to 2, -2. And also this piece. So that goes to infinity there. So that's going to be 2 to infinity. And that's it. Thank you. Have a nice day. Bye-bye.